Hello, Algebra 2. This is your last set of notes for the year, so that's pretty exciting. We'll just be reviewing for the SOL test after this, and then reviewing for the final after the SOL test. So the day 4 for Unit 9 is going to be talking about the z-score. And you may remember this formula from Algebra 1, and it's on your formula sheet, so you don't have to memorize it. And the z-score is x sub I minus mu divided by our standard deviation. So you'll take a data point, subtract the mean from it, and then divide by the standard deviation to find the z-score. What a z-score tells you is how many standard deviations the data is away from the mean. It allows you to compare different data sets. So remembering our example of the rugby players, we could compare the average heights of rugby players to average heights of a different sport by looking at their mean and how their average is distributed. You can use the z-score to compare the different data sets. So that's why we have the z-score. And what should the total area equal under the curve? So under our entire bell curve, the area should equal 1. And then also understand if there is, so that's a probability. Remember, all of our probabilities should add up to 1. And then if they're asking for the probability as a percentage, like a lot of our questions in these notes are, then 100%, you were going to think about the area under the curve would be 100% of the data. Okay, so again, the z-score tells you how many standard deviations the data is away from the mean. And remember that the mean is mu and sigma is the symbol for standard deviation. Okay. So our first example here is asking us what percentage of rugby players are taller than 186 centimeters. So first, let's just keep practicing drawing our normal curve, making it as symmetric as possible. And our mean, remember, is the average, so it's right in the center of our data. And remember from our problem from our day 3 notes, this is the same data set we're talking about. Our mean was 179. And this one is asking about if they're taller than 186. So remember we had to add to get up our standard deviations. Remember our standard deviation for this example was 7. And our mean was 179. So we'll be adding 7 to get to 1 standard deviation, and that's 186. Okay, so this question they're asking what percentage of the rugby players are taller than 186? And they just said to shade it. So taller, everyone taller would be in this section above 186. Okay, so that's shading the probability on your curve. Our second example, they want us to now find the z-score for 186 centimeters and mark your diagram appropriately. We know our z-score is 1, right? When we determine that, that is our z-score. But let's go ahead and find it using our formula. So you remember how to do that. Remember the xi will be the data point that they want us to find, so 186. And then subtracting the mean, so 179 in this case, and then dividing by the standard deviation, which is 7. So 186 minus 179 is 7, and 7 divided by 7 is 1. So our z-score is telling us that where it falls on the normal curve. So that if it fell in between here, you would expect to have a z-score between 0 and 1, because our mean would have a 0 z-score because it would fall exactly. Our 186 would have 1, and then remember from the previous night notes, 2 standard deviations. So if we got a z-score of 2, that would be 193. A z-score of 3 would be 200, the value of 200. So if we had a person that was 195 centimeters, they would expect to have a z-score between 2 and 3, and closer to 2. Similarly, if you had a -1 z-score, it would be 172, a -2 z-score would be 165, and a -3 would be 158. So let's keep practicing this and make sure we understand. So our z-score is telling you where it falls on the normal curve, above or below. If it's positive, it falls above the mean, and if it's negative, it falls below. So again, the z-score tells you where the data point falls on the normal curve, and if the z-score is positive, the data point is above the mean, and if the z-score is negative, the data point will be below the mean. Okay, so now we're going to be using how to use our calculator. There is a couple different ways to find our probability. We can use our calculator, we can use the calculator with the z-score, the calculator with mu and sigma. We also can use the chart, the z-score chart. So we'll be practicing that chart in class. But first, and this notice, I'm going to show you the calculator. So one of the first things we want to just be able to practice is find the z-score. So we're going to be using that formula that we wrote down. So the data point minus mean divided by the standard deviation. And our example is talking about fuel efficiency in miles per gallon of a Honda Civic, and it varies tankful to tankful according to a normal distribution. So the mean here is 34 miles per gallon, and our standard deviation is 3.5. Okay, before we start looking at all these questions, I want you to just draw your normal curve here and make sure you understand how to do the mean and count up with your standard deviation. So go ahead and pause the video and do that. So again, our mean would be at 34, and we would add the standard deviation as we go up. So at 1 standard deviation would be 34 plus 3.5, so that would be 37.5. So at 2 standard deviations, we'd add another 3.5 to get 41, and then at 3, we'd add another 3.5. From the mean going down, we'll be subtracting the 3.5. Remember our empirical rule. Within 1 standard deviation would be 68% of the data, and then within 2 standard deviation is 95, and then within 3 is 99.7. So as you're working through all these problems, make sure it makes sense with what your normal curve is showing you. Okay, so I went ahead and changed this on your notes before I printed it from proportion to probability. Most of the time they're going to ask as a probability or percentage, so I want to stick to those two vocabulary words. So remember, a probability would be a number between 0 and 1, and then percentage obviously would be between 0 and 100%. And so for probability, the tankfuls would get fewer than 30 miles per hour, miles per gallon. That would be when our x would have to be less than 30. So we're looking for the probability when x is less than 30. Okay, so we're going to be talking about this data here, all of where it falls in here. If we are going to use our calculator with the z-score, we'd actually find the z-score and then plug in. If we're going to be using our calculator with the mean and the standard deviation, then we're going to be plugging in with the normal CDF, and the lower, the upper, the mean, and the standard deviation. So we can find it three ways, like I said earlier. And if they give you the z-score, then our mean would be 0, and our standard deviation would be 1. Today's notes, we're going to be practicing mostly when they give you a mean and standard deviation and plugging into the normal CDF without finding the z-score first. But in class, we will practice the other two methods. So we're using our calculator, and I'll show you the calculator steps in a minute, but first let's understand what we're going to be putting in. So we're going to be going to the normal CDF on the calculator and put the lower limit. So we're looking for all the values less than 30. So I'm going to just represent all the values less than 30 as negative infinity, and I'm going to call that negative 1,000. And then, so all the values to 30 is what we're talking about. So our upper would be 30. And then our mean for our example, they give us is 34. And our standard deviation is 3.5. Okay, so make sure your graphing calculator is out. So, and your graphing calculator, to get to normal CDF, you're going to hit second and vars. And then see it's number 2. So then you'll plug in what we said. So our lower, we said, was going to be negative 1,000. Then 30, comma. Then our mean, which is 34. Then our standard deviation of 3.5. And hit enter. So we found our probability to be 0.127, because we would round up from our fourth digit. And let's make sure that makes sense to us. So this data, that does make sense, that would be a small percentage of the data, so 12.7%, but in this case it wanted probability, so we leave it as 0.127 of the data. Okay, question B is asking us for the probability of all tank fills that get more than 40 miles per gallon. So X is greater than 40. So that would be from here and above. So to find that using the calculator, we will put in normal CDF. So 40 is our lower limit, and then all the way to infinity, and we'll use 1,000 to represent infinity. And then again, the mean of 34 and the standard deviation of 3.5. When we put that in our calculator, using the same steps, you'll get 0.043. Okay, for our last for the video tonight will be part C here, and they're asking between. So to find between, This one's saying between 30 and 40, we find that x stays between 30 and 40, so our lower would be 30, our upper is 40, and staying mean and standard deviation. And when you put that in the calculator, you get 0.83.